Today we're looking at communications and connections. So communication matrix is a binary matrix. So binary just means when we use ones and zeros. So computer language, computer coding, I believe, uses ones and zeros a lot as well. So that's what binary. So our communication, you're only going to have ones and zeros. And what it means is we can use it to show that there's connections between things. And it might be people talking, or it could be other things like that machine's communicating with that machine or whatever. But let's have a look. So they're using here, they're talking about a network of people and how they could communicate with each other. So say they might be all multilingual, and so certain people can talk. So if I was going to set up a communication matrix for this group of people here, this example, you count how many people you've got. You've got 4 people here, so it will be a 4x4 square matrix, and we may as well just put the people like Vicky, Stephen, Kathy and Paul, and I'll do Vicky, Stephen, Kathy and Paul. So I have made sure there that this order across that way is the same way down that way. You have to make sure that's right. Okay, so then what we do is we go through and you can see, so we'll say this is the speaker and they're talking to, or the receiver over here. So first of all, is Vicky communicating with herself? Because you go Vicky to, I'll show you, sorry, a bit hard. Vicky to Vicky, I'm doing this point. So she cannot communicate with herself. We're going to say 0. We'll put a 0. Now, Vicky, can she communicate with Stephen? Yes, so we'll put a 1. 1 means they communicate. Can Vicky communicate with Kathy? Yes, so we'll put a 1. But she cannot communicate with Paul directly. So I mean directly. She can't look at Paul and talk to him. Okay, and then we can keep going. So we'll look at Stephen. Stephen can communicate with Vicky, not to himself. And can he communicate with Kathy? Yes, and Paul. So there I go. Kathy to Vicky, yes. Kathy to Stephen, yes. Not Kathy to Kathy. And Kathy to Paul, yes. Paul to Vicky, no. Paul to Stephen, yes, and Kathy, yes, and not to himself. So you can see you get this this 0 along 0, 0, and that sort of makes sense. That's like that's the redundant link. It's pointless. Why would you talk to yourself anyway? So always down that leading diagonal is a sort of a redundant. You don't really need to take that into account because it would be talking to yourself. So what we just did then, that's called first step communication, which means you you said who they could directly talk to. But what happens is you could then go do a 2-step. So I'll just to explain it why we're here. So 2-step communication matrix, when you actually set that up, what you're actually talking about is how can that person talk to the other person within 2 steps. So what do I mean by that? I could say Vicky could talk to Paul through 2 steps. She could go like this, 1, 2. Do you see that? So what that is one option of a 2-step communication. But she could also talk, so that would be, say, one option. But she could also do it this way, couldn't she? She could go 1, 2. Is that correct? So there would be a second option. And this is just for Vicky to go to Paul in 2 steps. And is there any other ones? Not really, is there? She can't go any other way. So what happens when you set up a 2-step communication between Vicky and Paul, just to show you, you would see a 2 here because there was 2 options, wasn't there? Yeah? Now, so that's what they're talking about. So we'll look at that a little bit later. But That's what a two-step communication is. They're telling you how many of those options there are, okay? So let's go and practice a one-step again with this Wong, Yummy and Kim down below. They can all speak different languages, like I said, and they want us to set up a one-step communication. So Eva, what was her name? Yeah, Eva to Eva, 0. Eva to Wong, she can talk, yes. Eva can't go to Yummy, or can't go to Kim directly. So straight up can't talk to them. So Wong to Eva can, Wong to Wong won't do it themselves, and Wong to Yuri, yes, and Wong to Kim, yes. Yummy, I keep saying Yuri. Yummy to Eva, can that happen? No. Yummy to Wong, Yummy not to themselves, and not to Kim. And the last one, Kim to Eva, no. Kim to Wong, yes. Not to Yummy and not to themselves. So that would be setting that up. All right. So here what we just were doing was a one-step communication. So that means you can directly talk. What we can do, and that's what I showed you in the red, is the two-step. Now, two-step, you can quickly find the two-step communication matrix. You don't have to go through and do it all. The way you can find two-step communication is you just get this one, the one step, and you raise it to the power of 2. Okay? So that's why we talked about powers before. So what we do is we raise it to the power of 2 and we end up with this matrix down here. So what it's telling me, so we're going to look at this one. Kimmy to Yummy, there is one option of two steps communication. So let's go have a look at that. So we're going to look at this. So from Kim to Yummy, or whatever her name. So see how they could do that, couldn't they? There's that one option, okay? With up here, they're saying that there's 3 options. There's 3 options to Wong to go to themselves in 2 steps. And if I show you there, and it's a bit silly because so Wong could go 1, 2, 1, 2, 1, 2, so back and forth. But it's sending a message to themselves, and that's pointless. So see how this line down here, that is the redundant link. Yeah, it's called the redundant because it doesn't make sense. Well, why would I send a message back to myself or do 2 steps to get a message back to myself? So that's the redundant link. So you sort of irrelevant. Often they'll say, what's the redundant, or take that out. All right, so here in your notes, we've said the redundant communication link. So that's that one on the diagonal, and it's when you're sending a message to yourself or the same person, and all of the non-zero elements we don't really take into account. So we don't need to take that into account in the matrix because it's like silly. All right. Down here, we've got an example of, down here where I'm reading this example here, it says the one in row Y, column K, represent 2 steps communication link that enables Yummy to send to Kim. So down here, how many 2-step communication links shown in C2 are redundant? So down here, we'll look at this one. They want to know how many links, links are shown in that. So you just would count them up. So you go 1, 2, 2, and 1. So that'd be that's 2, 4, 6. How many 2-step communication links are redundant? 6. Okay, because I added up the ones on the leading diagonal. Okay, the matrix below shows how 5 people, Alan, Bevan, Charlie, Drew, and Ether, can communicate with each other. And they're always going to give you out this blurb, and what they're going to say, number 1 means they communicate. So they always have to say that. In exams, they have to be clear. So you're always going to see all this blah, 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 blah. All right. So, and they'll give you an example to explain. So they're saying that between Charlie, a 1 between Charlie and Drew means they communicate. All right. So they said Isa, the question here is, Isa wants to send a message to Bevan. Which of the following shows the order of people through which the message is sent? So she wants to get a message to, Isa wants to get to Bevan. So what you need to do is you've got to be on the sender and you're at Isa. If you look, the only person she can actually communicate with is Charlie. So let's go. She's sent the message to Charlie. So now Charlie is in command of that message. Hey, we want to get to Bevan. Can he send it to Bevan? No, because there's no 1 on that. So he can either send it to Drew or back to Isa. We're not going back to. So now we're going to go. Now we're at Drew. Drew's got the message. Drew can either go to Alan or back to Charlie. So we're going to go to Alan. So if we look at what we've done, we've gone Isa to, who did we go to? Charlie, to Drew, to Alan, and now we're on Alan. And can Alan go to Bevan? Yes. So we've got that last one. So where was that option in my multi-choice? E. Done.